video we are going to show some basic data visualizations. We're going to use a facility, a package in R called ggplot2. Now R has several possibilities on how to draw graphs. The one that's built in the R base package is called plot, but plot is quite cumbersome to do. So ggplot2 is part of the tidyverse bundle of packages. So that's why, as usual in my videos, we are going to include the tidyverse library, and this will load the ggplot2 as well. Now the GG in the ggplot stands for Grammar of Graphics. The ggplot actually does two things. We tell it what do we want to draw, and that will be called aesthetics, and then we tell it how we want to draw it, and that's called geometries. So basically ggplot2, as the grammar of graphics, is plotting aesthetics using some geometries. Okay, so as an example for that, we are going to use an MPG dataset. MPG also comes in the bundle of tidyverse. So if we look at the structure of it, so this is data on the mileage of cars. We have in total of 244 cars in it, different manufacturers, different models, different displacements, years, and so on. So most of the illustrations in this video will be on this data set. So let's have a look first on how to do a bar chart. Now I already have the code, so it's going to be a little bit faster than typing it. So one possibility that comes with ggplot2 is the so-called quick plot. In quick plot, we basically just say, which data are we using. So we are using the MPG dataset, and then which variable do we want to plot. So if we just say, okay, quick plot class from MPG dataset, if we run this one, it will do a bar chart. Now, why does it do a bar chart? Well, it inspects the class, right? It sees that it's a string. And what can you do with a string? Well, basically what you can do with a string is you can just count it, right? And that's what it does, right? So this is your basic bar chart here. Now the same can be done using the ggplot command. So we can say ggplot. We could say here data equals MPG, or just MPG, it will guess. We are talking about the data because it will have a look and see MPG is a data frame, so this must be the data. And then, as we said, GG stands for Grammar of Graphics. And what we are doing is we are plotting aesthetics, AES or aesthetics class. So basically we are plotting the variable class from MPG. So this is our aesthetics, right? We are plotting class. And then for geometries, we tell it how to plot these aesthetics, so we plot the bar. And that's essentially it, right? So if I run this, I get the same graph as before. I just used slightly different command. Now, if you've noticed, I have these pluses. Now, basically in tidyverse, this goes for some others, I can often build commands as it goes like this. So basically I just start here with something and then I just keep adding other elements. So I started here with the data and the aesthetics, and then I added the geometry. I can add something else. For example, I could use a horizontal bars instead of vertical bars. So to use horizontal bars instead of vertical bars, I just add another element, and what I do, the other element is the coordinate flip, right? So if I run this one, I get the same graph, but now it's not the vertical bar, but it's instead a horizontal, because I flipped the coordinates. Now, if I want a clustered bar, in a clustered bar, I add another aesthetic. So here I need to tell, okay, so my X variable is class, but I want to fill it according to the drive. So actually what I want to see is for each of the classes, so for each of the drives, so it will be grouped by the drive, how many cars are in each of the classes. If I want a clustered bar, I say, okay, I want a bar, obviously, so geometry is bar. Then for clustering it, the position of different bars will be next to each other. That's why the command here is dodge, right? So it will dodge the other ones. And now if I really want to have the counts, now because I'm specifying this X, it will not know what to do. So I need to actually include some statistics, which was included in the previous calls automatically. So I call it statistic is count, so it will count the number of occurrences. So if I run this, I get this, I get the graph here. So you can see that the two-seaters are all rear drive. The compacts, I have several front drives, but some are four-wheel drives as well. Minivans are all front-wheel drives. Mid-sizes are mostly front-wheel drives. Pickups are all four-wheel drives, and so on. Now, the clustered in this particular case might not be the greatest idea. It would be much better to use a stacked graph. It will show me more. And basically what I would use is, I use pretty much the same composition here, with the difference that instead of position dodge, I tell position stack, and it will stack the graph on one another. So if I would run this command here, I get a stacked bar. Sometimes I would like, instead of stacked, I would like a percent stacked bar. So this filled up to 100%. And again, the only thing that I change is I change the position from stack to fill. And I get a third kind of graph. I can see here, so all minivans are front-wheel drives, all pickups are four-wheel drives. SUVs are mostly four-wheel drives, but some of them are rear-wheel drive, and so on. Now, for numerical variables, often a very useful graph to show the distribution of a numerical variable is a histogram. Now, histograms can be done from tables, and if they are done from tables, they look pretty much like a bar chart. But they can go from the original data, so I don't have to pre-order the data. I can use a quick plot here. So with a quick plot, it just guesses. So the usual guess for bins, so the number of categories is 30. I can see here there's a lot of empty bins. Might not be the best idea here. So what I could do is I can use a bin width of 5. So I specify the bin width, and I get a reasonably neat histogram for the highway mileage of the cars. I could play further a little bit with the histogram, but for our purposes, this is more than enough. Now, for time series, a very useful chart for time series is the line chart. Now, the line chart, so first what I need is I need a time series, and I will use the seatbelts time series. This is a time series. Now ggplot can't really handle time series. It expects the data to be a data frame. That's why when I'm using the data that's a time series, this is a TS time series object. If I just use here seatbelts, it won't work. But there's this very neat facility built into R that's called as. So basically any object, in this particular case seatbelts, can be transformed temporarily into something else. And what I'm saying here, well, for the ggplot purposes, use seatbelts as a data frame. So even though seatbelts is a time series, if I tell it as data frame, it will actually be used as a data frame, so ggplot can actually use it. Now this data set, it's actually a time series of road deaths in the UK in 60s, 70s and 80s, so before and after the introduction of mandatory seatbelt. And in the data here, what I have is drivers killed, how many drivers were killed, and then how many people in the front seats, in the rear seats were killed throughout some years. Okay, so let's start with here. So ggplot, seatbelts, I will try to plot, so on the x-axis, I will try to plot the time. Now, once I call this as a data frame, this doesn't contain time. Time is a very special thing, is a time series. But what I can do is I can use on the x-axis just time from the original seatbelt and then display killed drivers. So this is what I'm displaying. So two axes. On the x-axis I have the time. On the y-axis I have drivers killed. And what do I want to do is I want to plot a line. So the geometry is line of what? Of drivers killed over time. So if I run this, this is what I get. You can see here there's a lot of seasonality in this series. And so now if I want to have multiple lines, for example, if I want to have front seat depths and rear seat depths, what I can do is, okay, a ggplot, and I want a line from this data over time for the front ones in red, and I want a line from this data for the rear in blue. Right? So if I do this, I get two lines. You can see that over time there's much less deaths on the rear seats than on the front seats. And I could check actually here, the seatbelts were introduced, and you can see that mandatory seatbelts reduced deaths on the front seat quite extensively, whereas they didn't really have an impact for the deaths on the back seat. Another kind of graph to display relationship between variables is, two numerical variables, is the scatter plot. I can use the scatter plot as a quick plot. So from data MPG, so for example, relationship between displacement and highway mileage. If I just use the quick plot, okay, I have two numerical variables, so quick plot will guess, okay, the most appropriate graph for this is a scatter plot, and it will do a scatter plot. I can also use some different colors here in the scatter plot, so I can specify the color, for example, type of drive. If you remember, we have three types of drive: front, rear, and four-wheel. And you might notice here that so the four-wheel drives have a low mileage, so higher consumption, and that so the front-wheel driven cars have on average small displacement, whereas the rear-wheel driven cars have high displacement here, right? I can add a fourth dimension. So another way of how to drive a scatter, how to draw a scatter plot is by invoking ggplot, and then the geometry for a scatter plot is actually point. Here I need to specify, so I'm specifying, so the statics here, again I can do the same as above, so the statics are two variables, so this will provide two coordinates, and this will be displayed as points. So if I run this, I get exactly the same graph, but here I'm specifying more manually. The quick plot guesses more. Now obviously if I want to add a third dimension, so for example maybe I would like to add the number of cylinders in the engine. Size equals cylinders, so this is static will provide, so the first two, so this will provide x and y. I can even be very explicit saying like, so this is my x coordinate and this is my y coordinate. So I can be very explicit in this. So x and y coordinate, and then the size of the bubbles will be cylinders, and then I also color it by drive, so it's a very rich graph, but again it's points. Okay, so again I'm drawing points, and here we go. So as you can see, so low displacement engines have 4 cylinders, almost nothing has 5 cylinders, but then I have here 6, 7, 8 cylinders, cylinder cars. Now the last thing I want to show here is a pie chart. I don't have to do the tidyverse again, so I've done this before. It doesn't matter. Now, pie chart. R can't, or ggplot can't really do pie charts per se. So there's no command, so there's no geometry pie chart. But I can do something here. So there is a way. So essentially, what I can do here is I can take a bar chart and make it with adding some transformations, make it into a pie chart. So let's take just the first 2 rows of this command here. Okay, I'll need to make something, so just to make life a little bit easier, I'll just form a new variable called class. Now this bunch of commands, this is also part of the tidyverse. This is from deployer, and this command here is called pumping. Now basically what I'm doing is I'm counting the number of occurrences of different classes in the MPG dataset. Yeah. And what I do is I'm making a new data frame called class. So if I have a look at this class, class is essentially a frequency table of the classes in my original MPG dataset. Now, to display this, for example, what I'm doing here is, okay, I don't have an x, y equals n, and fill by class. And I do a bar chart, right? Stat equals identity is, it will just take the value of the variable, right? And what I get here is a stacked bar for the class. So something similar as we've seen before. Now, if I now rotate this, so what I do is actually I do a transformation. So I make coordinates from linear to polar, and I start at 0, and I do this for the y, and what I get is a pie chart. So basically a pie chart is just a transformation of a stacked bar. Now, if you would like the percents here to be displayed, what we can do is we can create some percent. So what we are doing is we are doing here a transformation. So we add the proportion to the class, again using the syntax of deployer. Yeah, sorry, I need this one. And I can do the labeling here. So you can see R follows the recommendations for good data visualizations. So pie charts are not a very good data visualization, so it doesn't really support pie charts, but if you want, you can do it. So that was a very quick review of basic data visualization with R. Thank you for your attention.